Good evening. Tonight we're talking about markets. Yes, markets. That thing you probably picture as a bunch of people in suits shouting at screens, a system that supposedly determines the price of everything from your morning coffee beans to your retirement fund. We're told it's the bedrock of our economy, a beautiful dance of supply and demand. But what if I told you that sometimes that dance is rigged? What if the game is being played with loaded dice? Because it is. And that's a massive problem, not just for the Wall Street big shots, but for everyone. Your pension, your savings, the value of your currency, it's all connected to this system. When someone manipulates it, they aren't just playing with numbers on a screen. They're playing with your money, your future, and your trust in the whole damn system. This isn't some abstract high-level threat that only affects billionaires. Think about it. When a handful of bad actors artificially inflate the price of a stock, regular people, maybe even your grandma, get lured in by the hype. They buy at the top, thinking they've found the next big thing. Then, the manipulators cash out, the price collapses, and grandma is left holding a bag of worthless digital rocks. This happens more often than you think, in both traditional stock markets and the Wild West of cryptocurrency. It's a sophisticated, high-tech version of a classic con, and it preys on the hope and optimism of ordinary investors. It undermines the very idea of a fair playing field, turning the market into a casino where the house not only always wins, but actively cheats to make sure you lose. So, why should you care? Because trust is the glue that holds our financial world together. When that trust erodes, things get ugly. People stop investing, companies can't raise money to grow and innovate, and the entire economy starts to wobble like a Jenga tower, with too many blocks pulled from the bottom. Fake markets create a domino effect of destruction. They reward cheaters and punish honest participants. They make a mockery of regulations designed to protect us. It's a systemic rot that, if left unchecked, can lead to catastrophic failures. And in that scenario, it's not the people who cause the problem who suffer the most. No, they've already parachuted out with golden briefcases. It's everyone else who is left to clean up the mess. The scale of this problem is staggering. We're talking about billions, if not trillions, of dollars being influenced by fraudulent activities. From pump and dump schemes, orchestrated in shady chat rooms, to sophisticated algorithms placing and canceling thousands of orders per second to create a false impression of market activity. The con artists have gotten smarter, faster, and more technologically advanced. They've graduated from cold calling you about a once-in-a-lifetime penny stock to building armies of social media bots to manufacture hype out of thin air. The old ways of policing the market, a regulator with a calculator and a very large cup of coffee, simply can't keep up. We are in a new era of financial fraud, and we need a new kind of cop on the beat. Alright, let's break this down. What exactly is a fake market? It sounds like something you'd find in a knockoff Disneyland right next to It's a Medium-Sized World After All. But in finance, a fake market is a very real, very damaging phenomenon. In simple terms, it's any situation where the price or trading volume of an asset is being artificially manipulated to deceive people. The goal is to create a false illusion of supply, demand, or value, tricking others into buying or selling at prices that don't reflect reality. It's the market equivalent of a magician using smoke and mirrors, except instead of pulling a rabbit out of a hat, they're pulling your life savings out of your wallet. Let's look at a classic example: the pump and dump. This is the financial equivalent of a pyramid scheme with better branding. A group of scammers will secretly buy a huge amount of a cheap, obscure stock or cryptocurrency. Let's call it idiot coin. Then, they unleash a massive marketing blitz. They create fake news articles, hire influencers to post glowing reviews, and flood social media with messages like, "Idiot coin to the moon," "Rocket emoji," "Rocket emoji," "Rocket emoji." This creates a frenzy of buying from unsuspecting investors, which, you guessed it, pumps up the price. Once the price is sky high, the original scammers dump all of their holdings, cashing in for a huge profit and causing the price to crash, leaving everyone else with, well, a pile of idiot coins. Another delightfully sinister tactic is called spoofing. This is where a trader places a large order to buy or sell an asset, with absolutely no intention of ever letting it go through. For example, they might place a massive sell order for a stock. Other traders see this and think, oh god, a big player's about to dump their shares, the price is going to tank. So they panic and start selling their own shares, driving the price down. Just before their big fake order is executed, the spoofer cancels it and then buys up the stock at the new, artificially low price they just created. It's like shouting fire in a crowded theater just so you can get a better seat. It's deceptive, it's manipulative, and until recently, it was incredibly hard to prove. And then there's wash trading. This is perhaps the most brazenly fake activity of all. This is when a trader, or a group of colluding traders, simultaneously buys and sells the same asset to themselves. Why would they do that? To create the illusion of high trading volume and activity. Imagine an online marketplace for, say, digital art. If a new piece of art has zero trading history, people might be hesitant to buy it. But if it looks like it's been bought and sold dozens of times in the last hour, it suddenly seems popular and in demand. This fake volume can lure in real buyers who think they're joining a hot market, only to find out the party was just one person wearing different hats and talking to themselves in a mirror. So, if we want to catch these digital crooks, we need to think like a detective, and every good detective needs evidence. In the world of finance, that evidence is data, a truly colossal, mind-boggling amount of data. To build an AI system that can sniff out manipulation, you first have to feed it, and it has a very specific diet. The first course on this data buffet is trading data, scraped directly from exchanges. We're talking about every single order placed, every trade executed, every cancellation made. This includes the price, the volume, the exact timestamp down to the nanosecond, and the anonymized ID of the trader. It's a relentless stream of information, a fire hose of numbers that, to the naked eye, looks like complete and utter chaos. But trading data alone isn't enough anymore. Why? Because the modern con artist operates on multiple fronts. So for our second course, we need to start scraping social media and news websites. We're talking about Twitter, Reddit, Telegram, Discord, and financial news headlines. The AI needs to see what everyone is saying about a particular stock or coin. Is there a sudden coordinated explosion of positive posts from accounts that were all created last week? Is a C-list celebrity suddenly tweeting about a cryptocurrency you've never heard of, complete with rocket emojis? This contextual data is crucial because it helps connect the dots between online hype and suspicious market movements. The pump doesn't happen in a vacuum, it's fueled by a narrative, and that narrative lives online. Now, once you've gathered all this data, you can't just dump it into the AI's lap. That would be like trying to make a gourmet meal by throwing a live cow, a bag of flour, and 3 chickens into an oven. You have to prepare the ingredients first. This stage is called data cleaning and pre-processing, and it's arguably the most important and least glamorous part of the whole process. The raw data is messy. It's full of errors, missing values, and different formats. You have to standardize timestamps, handle outliers, and structure everything so the machine can understand it. For text data from social media, this means cleaning up slang, removing irrelevant noise, and even trying to understand sarcasm, a task that is difficult for humans, let alone a computer. Without proper cleaning, your AI model will be, to use a technical term, garbage. It will see patterns that aren't there and miss the ones that are. For example, if a data feed from an exchange has a 1-second hiccup and reports a stock price of 0, a poorly prepared AI might flag it as a catastrophic market crash instead of a simple data error. Cleaning the data ensures that the AI is learning from a reliable, accurate picture of reality. It's the tedious, painstaking work that happens behind the scenes, but it's the foundation upon which any successful fraud detection system is built. It's the difference between a high-tech watchdog and a very expensive, random number generator. Okay, so we've got our clean, organized data. Now for the fun part, teaching the AI what to look for. The machine can't just find the fraud, you have to tell it what fraud-like in the data. These clues are called features, and they are the digital fingerprints that manipulators leave behind. An AI model sifts through millions of data points, searching for combinations of these features that scream, something sketchy is happening here. It's not looking for one single piece of evidence, but a whole constellation of suspicious behaviors that, when viewed together, paint a picture of manipulation. It's less like finding a smoking gun, and more like noticing the suspect bought a gun, gloves, a shovel, and a book titled How to Get Away with It. One of the most obvious features is abnormal price and volume movement. an AI can be trained to understand what normal looks like for a particular stock. It knows the typical trading volume, the average price fluctuations, and the usual times of day when activity picks up. So, when a sleepy penny stock that usually trades a few thousand shares a day suddenly sees millions of shares traded in an hour, causing its price to jump 500%, the AI's alarms start blaring. This feature, known as anomaly detection, is the first line of defense. It's the bouncer at the club who notices someone trying to walk in wearing a giant inflatable T-Rex costume and thinks, that's not our usual clientele. Another key set of features comes from order book data. The AI doesn't just look at trades that happened, it looks at the orders that happened. Remember spoofing? An AI can spot this by looking for a pattern of large orders being placed far from the current market price and then being cancelled just before they would be executed. It can also detect layering, a similar technique where a manipulator places multiple fake orders at different price levels to create a false sense of supply or demand. The AI can track the order-to-trade ratio for specific traders. A normal trader might execute most of their orders, while a manipulator might have an absurdly high cancellation rate, a clear fingerprint of their intent to deceive, not to trade. Finally, we have the features that bridge the gap between market data and social media chatter. The AI can be trained to perform sentiment analysis, classifying posts as positive, negative, or neutral. A crucial feature is the correlation between a sudden spike in positive sentiment online and a subsequent spike in the asset's price. The model can also look at the characteristics of the social media accounts themselves. Are the accounts new? Do they have very few followers? Are they all posting the exact same message at the exact same time? This is called bot detection. When the AI sees a surge of activity from a network of what appear to be fake accounts, all hyping the same asset that is also showing suspicious trading patterns, it can conclude with high confidence that a pump and dump scheme is in progress. Once you know what you're looking for, you need to choose the right tool for the job. Not all AI models are created equal. Think of it like a superhero team. Each member has a unique set of powers, and you need to assemble the right group to defeat the villain. In our case, the villain is financial fraud, and our heroes are different types of machine learning algorithms. There's no single best model. The choice depends on the specific type of manipulation you're trying to catch, the kind of data you have, and how quickly you need an answer. It's a strategic decision, a sort of AI Hunger Games where only the most effective models survive. First up, we have our classic reliable workhorses supervised learning models, like logistic regression and support vector machines, or SVMs. For these models to work, you need a historical dataset that has already been labeled. This means you need examples of what normal trading looks like and what manipulative trading looks like. A human expert or a team of them has to go through past data and flag known instances of fraud. The model then learns the statistical differences between the good and the bad. The strength of this approach is its clarity. It's relatively easy to understand why the model made a certain decision. The weakness? You need that labeled data, which can be expensive and time-consuming to create. You can only teach it to find frauds you already know how to identify. Next, we have the detectives of the AI world unsupervised learning models, such as clustering algorithms like k-means and isolation forests. These models are brilliant because they don't need labeled data. You can just give them a massive pile of trading data, and they will work to find the odd ones out on their own. They operate on the principle of anomaly detection. They learn what the vast majority of normal behavior looks like, and then automatically flag any data points that deviate significantly from that norm. Their great advantage is their ability to discover new, previously unknown types of manipulation that you haven't seen before. The downside is that they can generate more false alarms, flagging unusual but perfectly legitimate trading strategies as suspicious. Finally, we have the advanced, futuristic models, deep learning and reinforcement learning. Deep learning models like long short-term memory networks, LSTMs, are fantastic at understanding sequences and time series data, which is exactly what market data is. They can recognize complex, long-term patterns of manipulation that might unfold over hours or even days, patterns that simpler models would miss. Reinforcement learning is even more cutting edge. Here, an AI agent essentially plays a game against the market, learning through trial and error which sequences of actions are most likely to be manipulative. These models are incredibly powerful but are also the most complex, expensive to train, and hardest to interpret. They are the heavy artillery you bring in for the toughest fights.
Perfect.
Detecting fraud in a history book is one thing, detecting it as it's happening is a whole different beast. In today's markets, fortunes are made and lost in milliseconds. High-frequency trading algorithms can execute thousands of orders in the blink of an eye. This means our AI watchdog can't be a sleepy old hound that takes its time sniffing around. It needs to be a greyhound, running at full tilt, all the time. The challenge of real-time detection is immense. It's a frantic, high-stakes race against fraudsters who are moving at the speed of light, and if your AI is even a second too slow, the damage is already done, and the manipulator is gone. The first massive hurdle is the sheer volume and velocity of data. We're not talking about a gentle stream, we're talking about a biblical flood. A major stock exchange can generate terabytes of data every single day. An AI system needs to ingest, clean, analyze, and make a decision on this incoming data, literally, within milliseconds. This requires an incredible amount of computational power and a highly optimized data pipeline. You can't just run this on your nephew's gaming PC. We're talking about massive server farms, distributed computing frameworks like Apache Spark and Flink, and specialized hardware designed for high-speed data processing. The infrastructure alone is a monumental engineering challenge. Another huge problem is what's known as concept drift. This is a fancy way of saying that the cheaters change their tactics. The manipulative patterns that your AI was trained to detect last month might not be the same ones the fraudsters are using today. The market is constantly evolving, and so are the methods of manipulation. A real-time detection system cannot be static. It must be dynamic. It needs to be constantly retraining and updating its own models, learning new patterns of fraud on the fly. This requires a feedback loop where new data and the results of its own predictions are used to refine its understanding of the market, a process called online learning. So, how do we solve this? The solutions are as complex as the problems. To handle the data speed, engineers use techniques like stream processing, where data is analyzed as it flows in, rather than being stored and analyzed later. They also use clever feature engineering to create lightweight but powerful indicators that can be calculated almost instantly. To combat concept drift, many systems use a champion-challenger model. The current best-performing AI model, the champion, is constantly being tested against new experimental models, the challengers. As soon as a challenger proves it can detect new fraud patterns more effectively, it becomes the new champion. It's a relentless, never-ending process of self-improvement, because in this race, the moment you stand still, you've already lost. So, you've built your lightning-fast, super-smart AI. It's humming along, flagging suspicious trades left and right. Success, or is it? There's a huge lurking danger in all fraud detection systems, and it's called the false positive. This is when the AI flags a completely legitimate trade as manipulation. It's the digital equivalent of the boy who cried wolf. If your system sends out hundreds of alerts every day, and 99% of them are false alarms, people are going to start ignoring it. And when a real wolf, a real manipulator finally shows up, no one will be paying attention. Managing the rate of false positives is not just a technical challenge, it's crucial for the system's credibility and usefulness. The truth is, some of the most innovative and profitable legal trading strategies can look, at first glance, very similar to manipulation. A firm might be using a complex algorithm to manage a large position, which could involve placing and canceling many orders quickly. This is a legitimate strategy known as liquidity provision. An unsophisticated AI might see this high order-to-trade ratio and immediately flag it as spoofing. This is where the balance between sensitivity and specificity comes in. You want your model to be sensitive enough to catch the real crooks, but specific enough that it doesn't constantly harass the innocent. It's a very fine line to walk. Too far in one direction and you miss the fraud. Too far in the other, and you drown your analysts in a sea of false alarms. This is precisely why the human element is still absolutely essential. The goal of an AI detection system isn't to replace human analysts, but to empower them. Think of the AI as a brilliant but hyperactive junior detective who brings you a mountain of clues. It's up to the seasoned human expert, the grizzled, seen-it-all chief inspector, to look at the evidence the AI has flagged and use their judgment, experience, and intuition to make the final call. The AI can process data at a scale no human ever could, but a human can understand context, nuance, and intent in a way no machine currently can. They can investigate the trader's history, understand the broader market context, and ultimately decide whether an alert warrants a full-blown investigation. The best systems, therefore, are built around this human-in-the-loop collaboration. The AI does the heavy lifting, sifting through the noise to find the most suspicious signals. It then presents its findings to a human analyst in a clear, understandable dashboard, highlighting exactly why it flagged a particular event. The analyst can then quickly review the evidence, dismiss the false positives, and focus their valuable time and energy on the alerts that are most likely to be real instances of fraud. This partnership combines the raw computational power of the machine with the wisdom and judgment of the human, creating a fraud detection system that is far more effective than either could ever be on their own. So, you've deployed your state-of-the-art AI. It's working perfectly, catching spoofers and pump and dumpers. You've won, right? Time to pop the champagne and put your feet up. Well, not so fast. Here's the thing about fraudsters, they aren't stupid. They know you're watching. And, the moment you deploy a new detection method, they start working on ways to get around it. This creates a perpetual high-stakes game of cat and mouse, an endless technological arms race between the people building the security systems and the people trying to break them. The battlefield is constantly shifting, and victory is never permanent. This is known as adversarial adaptation. Manipulators will actively try to make their behavior look normal to an AI. For example, if they know an AI flags sudden large orders, they might break their manipulative orders into many smaller ones, spread out over a longer period. This technique, sometimes called iceberging, is designed to fly under the radar of simple volume-based detection models. They might also inject random noise into their trading patterns, placing a few random, legitimate-looking trades in the middle of a manipulative sequence to confuse the algorithm. They are essentially learning the AI's rulebook and then carefully engineering their strategy to avoid breaking the rules, even while their intent remains just as malicious. The fraudster's adaptation isn't limited to trading patterns, they are getting smarter on the social media front too. Early pump and dump bots were easy to spot. They all used similar language and posted at the same time. Now, scammers are using more sophisticated AI, like large language models, to generate unique, human-sounding posts. They can create entire networks of fake personas that build up a credible history over months before they are activated for a pump and dump scheme. They might engage in normal conversations, post about their hobbies, and then one day, casually mention a hot new crypto tip they heard about. It's astroturfing on steroids, and it's incredibly difficult for even advanced AI to distinguish from genuine grassroots excitement. So how can our AI systems fight back? They have to become adaptive themselves. This is where adversarial training comes in. You can actually use an AI to simulate the behavior of a manipulator. One AI model, the generator, tries to create fake manipulative trading data that looks as realistic as possible. Another AI, the discriminator, our detection model, tries to tell the difference between the generator's fake data and real, legitimate trading data. The two AIs compete against each other, getting progressively better. The generator learns how to better mimic normal trading. And the discriminator, in turn, learns how to spot even the most subtle, sophisticated fakes. It's like making your watchdog spar with a robot wolf every day to keep it sharp. Alright, let's talk about the elephant in the room, or rather, the lawyer in the room, holding a very thick binder labeled privacy regulations. While we're busy building these all-seeing AI systems to protect markets, we have to be incredibly careful not to cross major legal and ethical lines. The data that these AIs feed on, trading records, social media posts, even private messages in some cases, is deeply personal and sensitive. Wielding this data gives you immense power, and with great power comes the great responsibility not to be a total creep. There's a fine line between a market watchdog and a big brother surveillance state, and we need to make sure we stay firmly on the right side of it. The first major hurdle is data privacy. Regulations like GDPR in Europe and similar laws around the world place strict limits on how personal data can be collected, stored, and used. You can't just scrape up everyone's information and feed it into a black box. The data often needs to be anonymized or pseudonymized, meaning that direct personal identifiers like names and account numbers are removed or replaced with tokens. The challenge here is that this can sometimes make it harder to spot collusion. If you can't see that three supposedly separate traders are all actually the same person, you might miss a coordinated manipulation scheme. It's a constant balancing act between protecting individual privacy and ensuring market integrity. Then there's the problem of bias and fairness. AI models are trained on historical data, and if that data reflects existing biases, the AI will learn and amplify them. For example, what if a model inadvertently learns to associate a particular trading style, common among traders from a certain country, with fraudulent activity? It could end up unfairly targeting and flagging innocent people based on biased correlations in the data. Ensuring that these AI systems are fair and equitable is a monumental task. It requires careful auditing of the data, rigorous testing of the models for bias, and transparency in how the models make their decisions. A black box AI that flags someone for fraud without any explanation is simply not acceptable. Ultimately, the use of AI in market surveillance demands a strong ethical framework. This means being transparent about what data is being collected and for what purpose. It means having clear governance structures in place, with human oversight to ensure the AI is being used responsibly. It means building systems that are explainable, so that when the AI flags someone, an analyst can understand why. And it means having robust security to protect the massive, sensitive datasets from being breached. The goal is to build trust, not just in the markets, but in the systems designed to protect them, because if people believe the cure is worse than the disease, the whole endeavor is doomed from the start.